Hello class, this is Mr. DeVoe-Peterson, and this is a review of Chapter 1 in your wireless network security class. So I'm in the Vital Source website for the ebook, which link I gave to you in the course outline. And I'm looking at, go through the table of contents here, and I'm looking at Chapter 1. And just as a high-level overview, this chapter talks about describing different types of networks from large to small. Local area networks is what we think about and talk about within a building. A wide area is the biggest. Metropolitans in between. Campus might be a school campus or a campus with multiple buildings on the same property, businesses. And then the smallest would be your personal area network. And then it goes through and describes what a local area network is and shows items and things connected to that network. And why do we need to know that? Well, if we're going to do a wide area network, we need to know how to get a dedicated line to link the two separate local area networks. And that requires dedicated lines and so forth. So I'll jump past these descriptions, take a look at them. And then we talk about topology in general. And this talks about, from the beginning of time, how networks started out, and they started as a bus topology. That meant that everything was on the same line, and if you added or took away any of these devices, you had to sever the line and to make the connection or disconnection, then put it back together. So it was a disruption of service, basically. And as technology improved, then we went to a ring topology. Those network cards were quite expensive, actually, and this diagram doesn't accurately depict a token ring topology. The connections, actually, the circle is made within a switch device, a token ring device, where there's a circle where each device with a severed cable is pulled to send or receive information. But this illustration shows you the concept that everybody must wait for their turn to get or send information on that network. And what we see today is the star topology, where everybody can jump on and send and receive at the same time, and there's some protocols in place to cut back on collisions and things like that on the network when data is traveling from different sources on the same wire at the same time. Mesh means there's overlap, there's redundancy in the network. And then we have ad hoc, where we decide maybe we're in a library setting and we want to connect our laptop or phone to another device, and we just set up an ad hoc that for that moment, that network to use and then break down when you're done with it. Point to point might be when we just want to connect. In this case, this shows two tall buildings, and perhaps there's an obstruction in the way, and to run a cable underground might be cost prohibitive. Maybe there's a freeway there. So sometimes we'll do it wireless from the top of the buildings, from building to building, and connect that way. And sometimes we do that with multiple buildings, point to point. And then we get into, in Chapter 1, something called the OSI Model, the Open Systems Interconnection Model. And it's a framework, if you will, of protocols, where each protocol has a separate job to do. And we'll start from the bottom and we'll go back up. The bottom would be, okay, I'm sending information is going to get sent from my computer. How does it leave my computer? Well, it leaves it on the physical layer, right? And the physical layer has to do with the cable or the wireless, that connection where the data travels on as it leaves your device, right? That's the physical layer. Then we go to the data link layer, which kind of maps out your MAC address, and and it has what's called the logical link control. These two work together, and they're unique identifiers, so Mr. Switch knows how to get data to you and from you. Then we have the network address layer, and this is now we're leaving our our local area network, and we're going on the World Wide Web at this point. So we need an address to get out there, right? When you're in a business or school, you have internal addresses, and that can be repeated, and other businesses could use them for the Internet Protocol address for the devices in that building. But when you get out on the World Wide Web, that address needs to be swapped out for an address that can be routable on the World Wide Web. So we have information that we use so that when data comes back to you inside that business, like the MAC address and the network address, then it can be routed to you from Mr. Switch. You'll get that information. Okay, so we need some way to establish that connection And way back during the phone era, when engineers with Model were designing the phone system, it was what we considered a circuit-based connection, that once you establish a connection, that circuit was in place and intact for the entirety and duration of that communication session, and no one else could use that pathway, that circuit. Well, when networking came about, we switched our methodology from that circuit-based infrastructure to a packet-based, where your data might take different pathways to get to the destination or for you to receive that information. But we need a way to get that connection started, and that's with transmission control protocol, where we want to make sure we don't, the TCP, we don't drop any connections, any data, to maybe a less reliable, a more lazy one called user datagram protocol. And you might see that one used when you're streaming audio or video, where it's okay if you drop some packets. So speed is more important than getting all the data across. So there's some connection-oriented protocol there. Session layer has to do with making that connection and opening and closing that connection from system to system. Then we're going up the OSI model, the diagram, to the presentation layer, where it's getting ready to be presented to you in your application. Now maybe that's email, maybe that's a web browser, maybe it's an encrypted file that needs to be unencrypted so you can view it. It's getting ready to be presented to the application, and then you interact with the device, the computer, whatever that network device is, with the application layer. That's where you interact with it, and then we go back down the pipe. So going up here again, let's take a little look. I went to the physical, the data link network. We're getting ready to cross into a different network. Transport session, that has to do with the handshaking and the duration of the communication being intact. Presentation has to do with formatting for the application. So these layers are important for several reasons, because we have interoperability between network devices for the different manufacturers, and they have to follow certain protocols for devices that work at these different layers. And when we're troubleshooting a network connection, we need to know, well, where is the problem occurring? Is it the application is not presenting the information correctly, or is it not even transmitting outside my computer, which might indicate a physical layer of connection, like a cable got bent or cinched or something. So the separation of these different tasks into these different protocols helps us identify and troubleshoot networking. It just makes the job a lot easier to maintain those connections. So it's important that we know the OSI layer, and this walks you through coming down the pipe and going up to the next system and back. And the application layer doesn't just swing across to the application layer, the destination. It has to go down through these layers, and each, starting around here, our transport network, in each of these steps, then that data is put in, your data that you send is put inside another package, if you will, and we call that encapsulation, where we might, and I guess to describe that, it's like putting one envelope inside another envelope and adding data to the outside of the envelope. That's encapsulation. And this is convenient. So it talks about it here. It walks you through, and you can see the different headers that are put on the files that travels down the OSI model, and then they get stripped off when they get to the destination, so that the recipient can get that data at their application layer, if you will. Device addressing, this is kind of important. We talk about your physical address. We have a network card. It's got a unique MAC address, and that has to do with this the numbering system. Part of the numbering system is the manufacturer information, and the other part is the unique address for that manufacturer. And then we have what's called another address that we use, our network address, right? Local addressing. And this is showing it to you, and it's got this unique unique number that goes with the Internet Protocol address called the subnet mask address. And all that is the subnet mask address. We use this one number, right? This IP address, and it represents certain things. It represents the network, right? The first part of it's the network, and the last part of it is your address, your device address, right? The address that was given to you from the network. And we need a subnet mask to mask out the different parts, right? Some of it is the network address, some of it is your address for your device. Okay, what else? Let's see. Yeah, dotted notation. That can be a little tricky, but you know, we work in binary with computers, on and off signals, not base 10 but base 2, right? So it's a series of ones and zeros for binary. And this is how to get your internet protocol address. You can do a command, I'm looking for it here. Oh, ipconfig, here it is. And this gives you a little bit of address, but you can get more information about the network if you add a slash and another command. I think that's coming up. Yep, here it is. /all gives us all the information. And this is actually the exercise for chapter 1 for you to do for this chapter. And then there's a concept that's really kind of important called a network address translation, or NAT, and that has to do with the internal address within an organization and then the address outside on the web, right? There's a private side. The left side is a private side, but when we go out on the web, that private IP address for your device gets swapped out for an address that's routable on the internet, right? Because many businesses, you know, they follow this numbering convention, some of them very similar, within that organization that other organizations can do. And there may be a device with an IP address of 192.168.0.2, and if you have a router at home, yours may be 0.1, right? And there may be some devices on your network like printers and TVs that are 0.3, 0.4, and so forth. But that address can't go out on the internet. It's not routable. So we need to go through Mr. Router and it gets swapped out for a routable address on the public side. Here it is here. And that address comes from your internet service provider. You're leased an address for a certain amount of time, and then it gets renewed. So that is chapter 1. So take a look at it. A lot of good information. Much of this you probably had in CIT 15, I'm sure, and you recall some of this. So it's kind of a refresher. Look at it, see if it makes sense. And if you have any questions, send me an email. All right, thanks.